So in this video, we're going to be talking about what implicit differentiation is and how to do it. So before you learn how to do it, it's useful to understand why it is called what it is. And so, as you might guess, since we have the word differentiation in here, we are going to be taking derivatives. So implicit differentiation is all about taking a derivative. However, what makes it implicit instead of explicit is the form that the equation has been given to you in. So it's helpful to understand first what an explicit and what an implicit equation is. So for example, if I had something like y equals 3x plus 4, this is an explicit equation. And the reason why it's explicit is because we know exactly what y is in terms of x. We have all our y's on one side and all the x's on one side, and I can tell you exactly that if you have one y, if we want to express that in terms of x, one y is going to be equal to 3x plus 4. So it's explicit because we know exactly what y is in terms of x. But where we might see something called an implicit equation is if we had something like y squared plus y equals 3x to the 5th minus 7x. And so this is an implicit equation. And that is because even though all of our y's are on one side and all of the x's are on the other side, we don't know exactly what y is in terms of x. I couldn't say that one y is equal to something in terms of x. I don't know what that is. So in order for an equation to be explicit, we need to know exactly what one y is equal to in terms of x. But over here in this equation, we have y squared plus y is equal to 3x to the 5th minus 7x. So we don't have one y over here. So that is what makes this an implicit equation. So the relationship between one y and x is not super obvious. So this is why we might need something called implicit differentiation, is if we are given an equation that looks like that and we are asked to take the derivative of it. Almost all the derivatives we've seen so far have been equations that are explicit. We have just y on one side and then all the other x stuff on the other side. But if we have something like this equation down here, it is going to be trickier to take the derivative. And you might be wondering, well, couldn't I just rewrite this equation so I have one y on the left side and everything else on the other side? And you could definitely try, and sometimes you will be able to do that, but this equation that I've written right here is an example where that's not possible. You can try to work it out yourself. Try to get just one y on this side and then only x's on this side. It's not going to end up working. It's impossible to do. So if we're stuck in a situation like this, we have to use a technique called implicit differentiation, which isn't too tricky, but for some reason is one of the number one things that trips calc students up. So it's worth just looking at a lot of examples. So here I've written down an implicit equation, and it's implicit because we don't have just one y on the left side. We have y squared. And what we want to do is we want to take the derivative of this. And now you might be wondering, well, if I just square rooted both sides, then wouldn't I have just one y left over here? And yes, that is true. You could do that and that would work in this situation. But as we saw in the beginning, there are some situations where you won't be able to get just one y on the left side. So it is worth learning implicit differentiation, because the AP test will definitely give you a situation where you have to use implicit differentiation. So instead of taking the square root of both sides, we are going to use implicit differentiation. And so what implicit differentiation does is it wants us to take the derivative of this equation, and we are going to be taking the derivative with respect to x. And so now taking the derivative of the right side of the equation should be fairly straightforward, right? Using power rule here, 3x to the 5th, the derivative of that is going to be 15x to the 4th, and then the derivative of 7x is just going to be 7. But now, if we want to take the derivative of y squared, it's a little bit trickier, and you might kind of have an idea of what to do. It's a really similar process that we use in related rates. So when we take the derivative of y squared, we're taking the derivative of this whole equation with respect to x. That means x is our independent variable. So when we're taking the derivative of y squared, we have to treat y like a function. Y is not the independent variable. So it's really tempting to look at this and say, oh, the derivative of y squared is going to be 2y. But that is not complete. That is not entirely accurate because y is a function. And so what rule do we use when we have functions inside functions and we want to take the derivative? Hopefully you'd say chain rule, right? Chain rule says that we take the derivative of the outside, keep the inside the same, and then multiply everything by the derivative of the inside. And in this case, the inside function is y, and our outside function is the squared. So we are going to use chain rule on this y squared piece. So chain rule says we take the derivative of the outside, so the outside function is this squared, so we're going to bring the 2 down, keep y, the inside, the same, and then subtract 1 from the exponent. And then chain rule says we need to multiply all of that by the derivative of the inside. So if y was our inside function, the derivative of y is just going to be dy dx, right? And so now we have our derivative. And our end goal, usually on the AP test, or the end goal that they want you to do is they want you to write dy dx on one side and everything else on the other side. So while what we have here is correct, this is the derivative of what we started with, it's not in the final form. So the AP test will usually want you to have dy dx by itself on one side and everything else on the other side. So if we want to do that, well, we have 2y times dy dx. So if we want to move this 2y to the other side, what should we do? Well, we should just divide both sides by 2y. So when we do that, we'll have dy dx equals 15x to the 4th minus 7 all over 2y. And so this is probably something you're not super used to seeing, is having a y in your derivative, but that will very commonly happen with implicit differentiation. When you get dy dx by itself, the other side of the equation is almost always going to have both x and y in it, and that is perfectly normal, and that is okay, because that was our whole goal, was just to get dy dx. And so we did that, and when we differentiated, we treated x like normal, and we treated y as a function. So now we're going to look at another example, because I think just doing these over and over again is probably what's going to make you the best at them. So let's say we have y cubed minus 4y squared, and that is equal to x to the 5th plus 3x to the 4th. And we want to take the derivative of this. So again, we're going to have to use implicit differentiation in this one, because there's no way we could get just one y by itself over here on the left side of the equation. So we are going to have to use implicit differentiation, because we can't write y explicitly in terms of x. So we are going to take the derivative of this whole thing, and remember, we are taking the derivative with respect to x. So x is our independent variable, and y gets treated like a function. So we'll take the derivative of the right side first. So when we're doing implicit differentiation and we're taking derivative of terms that have x in them, those just get treated as normal. So x to the 5th, the derivative of that is going to be 5x to the 4th. And then the derivative of 3x to the 4th is going to be 12x cubed. So that is the derivative of our right side. And now we need to take the derivative of the left side. So if we're looking at y cubed, our outside function is this cubed, and our inside function is y, because y is not the independent variable. It's a dependent variable, so we have to use chain rule when differentiating. So if we take the derivative of the cube piece, the outside, that is going to be 3, bring down the 3, and then the inside stays the same, and then we subtract 1 from the exponent, and then chain rule says multiply everything by the derivative of the inside. So the derivative of y is going to be dy dx. So 3y squared times dy dx was the derivative of y cubed. And now we need to subtract the derivative of 4y squared. So again, y is a function, so we're going to use chain rule. So chain rule says derivative of the outside first. So we're going to bring that 2 down, and it will get multiplied by that 4 to give us 8. And then the inside needs to stay the same. We subtract 1 from the exponent, and then multiply all of that by the derivative of the inside. So the derivative of y, again, is dy dx. So this whole equation right here is a correct derivative of what we started with. But like usual, the AP test is going to want you to get dy dx on one side and everything else on the other side. So now this one's a bit tricky because we want to get dy dx by itself on one side, but dy dx shows up twice, right? We have two terms that have dy dx in them. So this is a super common situation that will probably show up on the AP test, and a lot of people kind of get stuck here. They go, I have two dy dx terms, I don't know how to get those by themselves. And so what you're going to need to do here is factor. You are going to need to factor the left side of the equation. So what I mean by that is we have dy dx in both these terms, so we can factor a dy dx out. So when we do that, we're going to have dy dx times 3y squared minus 8y. So what I did is I factored the dy dx out of both these terms, and that'll all still be equal to 5x to the fourth plus 12x cubed. And so now our end goal is to get dy dx by itself, so all we need to do is divide both sides by this term. So when we do that, we're going to have dy dx equals 5x to the fourth plus 12x cubed, and that will all be over 3y squared minus 8y. And so that would be your final answer because we have dy dx by itself. So whenever you have multiple dy dx's show up when you do the first step of differentiating, you're almost always going to have to factor. That is going to be the key to getting dy dx by itself. And now another thing that I want to bring up that, at least to me, is really important is when you see your teacher do these problems, instead of writing dy dx, you might see them write y prime. So y prime and dy dx are equivalent. They mean the same thing, and you can use either. And on the AP test, that is totally fine. You can use either. But I super recommend that you use dy dx. And so my reasons for that is, one, if you use y prime, it's really easy to forget to write the little prime symbol. And if you do that, if you forget the prime symbol and just write y, then you're gonna mess your equation up, right? And you're gonna not end up getting the right answer. So that's one reason, is that I see people do that a lot. When they use y prime, they forget the little tick mark, and just that one little mistake will make your answer wrong and screw things up. The other reason is that dy dx using differential notation like this, one is it's really good practice just using differential notation, and in other kinds of problems like related rates problems, you have to use this notation. So I think it's just super valuable to get as much practice as you can with this notation, and so it is for those reasons that I super recommend that you use dy dx. Yes, you can use y prime, and that is fine, that's correct, but I just really think it is to your advantage, and you'll probably make less mistakes if you use dy dx. The last example that we're going to look at in this video is x times y plus 3y squared, and that is all equal to 4. And we want to take the derivative of this. So we're going to use implicit differentiation because we have an implicit equation. And so we are going to take the derivative of this with respect to x. So this kind of problem is probably the one that people mess up the most in implicit differentiation problems. And the reason why I say that is because, like, okay, if we were to do the first step of this differentiation, we take the derivative of x times y. And whenever we have the independent variable times the dependent variable, it's not super obvious, but we have to use product rule to differentiate this, right? Because product rule is what we use when we take the derivative of two functions that are being multiplied by each other. And that is the case here, right? We have x times y, and y is a dependent variable. It represents a function. So whenever you have the independent x and the dependent y being multiplied by each other, you have to use product rule, and that is probably the most commonly made mistake, is not using product rule and trying to do it some other way. So make sure you're really careful when you have x's and y's multiplied by each other in implicit differentiation problems. That is a very common source of errors. So what that's going to look like then is product rule tells us that we take the derivative of the first and keep the second one the same. So in this case, my first function is x and my second function is y. So if we take the derivative of the first, the derivative of x is 1. And then we're going to keep the second function the same. So that'll be y. And then product rule tells us we have to add the first function kept the same times the derivative of the second function. And what's the derivative of y? Well, that's just dy dx. So this whole thing right here is the derivative of xy because we had to use product rule. So be really, really careful about that. Okay, so that's the derivative of that piece, and now we just need to take the derivative of 3y squared, and this is going to be chain rule. So chain rule says we take the derivative of the outside, so we have to bring that 2 down, multiply it by that 3, and it becomes 6, and then subtract 1 from the exponent, and then chain rule says we have to multiply everything by the derivative of the inside. So that'll be all times dy dx. And this is all equal to the derivative of 4. And what's the derivative of any constant? That's just 0. So this is our derivative of this equation, and now we just need to get dy dx by itself. So I'm going to simplify a little bit. The 1 times y is just y, and then we have x times dy dx, and then we have plus 6y dy dx. So I just wrote everything without the parentheses. I think it makes it a little easier to do the algebra. And so now we want to get dy dx by itself, so I'm going to subtract y from both sides. So after we do that, we'll have x over x times dy dx plus 6y dy dx equals negative y. And so now what's the next step? Well, we have dy dx show up twice. And so when that happens, you need to factor a dy dx out. So if we factor a dy dx out, we're going to have x plus 6y in the parentheses. And that's all equal to negative y. And then the last step to get dy dx by itself is divide both sides by x plus 6y. So our final answer, dy dx, is going to be negative y divided by x plus 6y. And so this is our final answer. And so that one was a bit tricky because not only did we have to use chain rule when we took the derivative of 3y squared, but we also had to use product rule when we did the derivative of x times y. So make sure you just do, I'd say just do a lot of these problems, and do a lot of problems where you have to use multiple rules like this because it's really easy to forget because you're not used to having to do this. So, and I would also really recommend that you use dy dx instead of y prime, although both of those are correct. So hopefully this video was a helpful intro into implicit differentiation, and hopefully those tips will help you make less mistakes. If you want to see any other examples or you have any comments or questions, make sure you leave that below, and don't forget to subscribe.